Hey everybody, how's it going? It's been a while. Good to see you, Nelfs, Hilbert Curve, or Nell FS. I'm not sure if that's like file system. Stilltree, Essie Woods, Flare YouTube, and Sam. How's it going, guys? It's good to see everybody. So today, and I turned off the music too, just so that I can hear like any notifications that Twitch gives me, because I've been missing them on streams, I've noticed. So no music today, but we can go back if you guys would prefer it. We'll see. So today, I think we're going to just be working with Asymp, which is a 3D model library importing thing. I haven't really done that much in regards to the game over the past couple weeks. It's mainly just been like preparing for the next video and stuff, and even then I haven't done much with that too. I haven't really done much in general except work, because work's been pretty busy. But if we take a look at what we've got, let's go ahead. I think this is on the launcher, which is what I was last working on whenever I was working on this stuff. Yeah, so I was working on the launcher, and basically I added in a few different things. One thing that I added in is this will, whenever it prompts you to update, it will actually prompt you to launch this in admin mode. That way you can actually install the files, because the default install directory is, if we open up a new one of these guys, I believe it's in like Win x86. It shouldn't be in x86, but that is where it's going. I think it's in here. Let's see. Yeah, Crumble Launcher. So the default install directory is here, and you can see I was having problems still because this isn't working correctly. It didn't delete the old files. But basically, it needs to launch in admin mode to do anything in this directory. So that's what I was working on last. And then I also added something else, which is basically a detection thing to see if you're running in OpenGL, like if you support OpenGL 4.6 or earlier, and then I can fall back to an earlier method if you don't. I think it's in window.cpp. I just do it when you create or initialize your windows. I think it's in here, which maybe this isn't the best place for this too, but is it in here? No, I am doubting myself. It's been a while, so I haven't been in the code or anything for a while. Okay, yeah, it's right here. Girlfriends. Gabe, so excited getting interviewed for an internship at TikTok. Wow, that's pretty awesome. Hopefully it goes well at the company and stuff too. I haven't heard anything about TikTok's company, corporate culture and stuff, but hopefully it's good. And Flare YouTube just got a new PC, also awesome. So it sounds like it's going pretty good. So basically what we can do to check and see if they support OpenGL 4.6, Sam, you need to fall back to 4.3 since your brother could not run on 4.6. Yeah, that's what I'm finding with a lot of, or with some people. I think I'm going to fall back to 3.3, which should support virtually everything. I don't think I'll have any problems with that. And it shouldn't be too hard to modify some stuff to work with that. But basically what you can do is you can just get the version, the vendor, and then I log all this stuff out so that I know if I ever need to look into logging details. And then we can get the version major and minor, which I just parse out using a very simple function that basically just gets the numbers between the dots, because it'll always be like 4 or 3 dot something. And so I basically just parse out that and then get the first number for the major and then second for minor. And why did I go down? So you can also like potentially have a third one. I don't care about that. That's just like a hot fix or something. But yeah. So basically I do that and then I print out what version it is. And so then if we were, say, in version 3.3, if I hard code this instead of actually parsing it, what will end up happening is in the launcher, once it launches, yeah, it's going to say old GL version detector. Looks like you're running an older version of OpenGL. It tells you what version. And it says update your GPU drivers to the latest version if they are not already, to get the best gameplay experience. So basically just tell the user, hey, like this isn't good. And then if you go below that, then it's just going to say like, hey, I'm not supporting this. So if I was at 3.2, then it's just going to be like, yeah, I'm not helping you out. Yeah, so then I just pop up GL version not supported. Looks like you're running an older version of OpenGL. This version is not supported, so the game may not work for you. And I put my email there. I'll have to have an actual bug reporting thing and everything sometime in the future. But yeah, so that's how I'll end up testing things too. I don't actually have OpenGL 3.3 supported yet. Plan on adding that pretty soon though. Langors, how's it going? Everything is going good here. Hope it's going good with you as well. And Essie Woods, not sure if you have already asked, or will it just be a PC game or console as well? For now, just PC, but I think it'd be cool to play around with console sometime way in the future. I need to keep working on it and actually get stuff kind of polished though. So yeah. Nelfs, are you using OpenGL for convenience? I'm using OpenGL because I don't know any other graphics APIs yet. I want to learn Vulkan, but have not learned it yet. So I'll eventually do that. And OpenGL is simple enough. It's fast enough. So no problems there for me, you know? But yeah. And Langor is all as good as well. That's good. Cool. So that's basically what I've been doing. And then another thing, what else was I doing? There was one other thing. So I did that, which basically detects the OpenGL version. I think that might be it. Oh yeah, and then log files. That was the other important thing. So you actually get log files printed out now, which is good. So if we go into roaming and then Crumble Launcher, there's logs. And if it crashes, so if we have an assertion failure, I've changed things up a bit. So let's go, say we were in our app and then... Is this it? No, this is the wrong one. If we were in the launcher app, which is the one I'm debugging right now. So let's say we were initializing and something failed. We say like G logger assert false, critical assertion failed here. So let's say we just have some assertion fail or whatever at runtime. What do we want to happen? Well, we want the user to be able to like find that bug report and stuff, and we want to sort of capture it and do stuff. So now on Windows, and I'll add like feature support on Linux and stuff once I get around to it, it pops up a little message box that says, hey, critical assertion failure. It tells you the exact line. It tells you the log that failed. And then it tells you where the full log file is at. Eventually what I'm going to do is instead of printing this, I'm going to have it like automatically send a bug report or something, because I think that's probably the best way to go. Or I may just have this be a message box that says like send a message or send a bug report, yes or no, submit a bug report. And then that will automatically send it and stuff. But yeah, this way we can at least capture these types of bugs. It does require an assertion to be thrown. So if I don't have the assertion there, it's not going to catch it, which isn't the best, I guess, but it will try its best to do. I don't know. So that's why I have assertions everywhere. And let's see. Crumble does have a launcher, yeah. And Heavy Rain 2.6, totally not DirectX 12 plus GNM. Not sure what that is. The main problem with C and CPP, in your opinion, is like organizing, making a simple Vim-like editor using curses or nurses. And I got so fed up of organizing C code, just made everything in one file. Yeah, I mean, I don't know. I think it's pretty much the same as like any other language, yeah. Okay, so that's basically what I've been working on though. Let's go over, we're going to switch our thing to be running, let's see, where is it? This thing. Okay, here we go. We're going to set this as our debug project because I want to go back to developing stuff for the game. Oh, and I have fixed up the game too, because there was still some stuff like UI stuff that wasn't completely correct. It's still not perfect, but it's better than it was. So there's still that, and then there was some problems where like, yeah, I think it was just UI problems. So I basically fixed all that up and then made sure that the game's running correctly again, so it all works out, which is good. I've also started converting everything over to RML UI instead of my old UI library. So sort of been going through that process as we're waiting for this to compile here. How is Launcher made C++2? Yep. So basically I have the engine, the core of the engine separated from the actual game. And so we've got the launcher, which runs on the engine, which sort of does all the big stuff for us. And then we've got the game, which also runs on the engine, and they both just sort of use that, and it does the basics. Okay, this says this should return. I was making some changes, I guess, that I forgot about. So let's see. So that's good. Okay. Don't know how I missed that, but... So let's go try and build this again. Hopefully this works. I think it works. I hope I didn't just leave this at like a point where it wasn't working and was just like, oh, okay, I'll work on this again later. Just like Super Mario Brothers or Super Mario Bros, now Crumble is Super Gay Bros. This is another thing too. I guess I did forget about this too. I've started changing up the menu. My brother made the design, so this is a screenshot from Minecraft, not from Crumble. But it's kind of like an aspiration, I guess. And eventually this will not be a screenshot. It will be an actual like chunk, and we'll have like birds flying around, all that type of stuff. Yeah, I know. My brother came up with the design and everything, so I really like it. And then once you click play game, it just goes back to the old design for now. But we'll eventually have the rest of the stuff here. So yeah. So we got that. And then if I open up the world, I think this should still all work properly. Fingers crossed. And it does. Cool. So we're getting some nice smooth frame rate. If I F3, yeah, we're getting 60 FPS. Everything's looking good. No warnings, no errors. All that stuff's good. And then you also notice too in the logs, if we scroll up to the top now, we get GL version 4.6.0 with vendor, the renderer, which is the graphics card, and the GLSL version. So we get all that stuff, which is good. So that whenever I'm debugging, I can sort of figure out what the system specs are. It would be nice to also include like CPU version and all that stuff as well, and how much RAM's available, all that type of stuff, which will all be coming in due time. But yeah, this is how the game's going so far. What are my plans for today? Well, my plans for today are, we have these 3D models, right? And right now, I still need to fix the colored lights too. I don't think they're correct. But yes, I do not think they're correct still. Yeah, they're not. I'll fix that eventually. Anyways, though, we have these 3D models, right? And these 3D models are currently like hand coded. That's not right. Wait a second. Okay, so if I do this, I'm just double checking that command prompt is picking up all my keyboard inputs. That's not cool. We'll have to fix that. So that's another thing I gotta fix, I guess. Command prompt is broken. Oh, and I guess you guys can't really see that because of the screen. Sorry about that. Okay, maybe I'll move that over in the future, like the Twitch stuff. But anyways, these blocks are currently like hand modeled inside YAML files, and I really don't like that because it's very area prone. It's not fun. So what I want to do is I want to be able to model these in Blender, and then we'll import it using Async, and then I will extract all the useful data and stuff through that, and then we'll have like a kind of a config file which sort of figures all that stuff out for us. And so then we can design stuff in Blender, just import it, and then it should all work out and get chunked properly. So that is the plan. We'll see if it actually works out. And let's change the FOV to 70 too, because I still am getting complaints about the FOV being too low. Don't know why, but I thought like a traditional FOV was like 45, but I guess it's more like 70 is the proper one. So yeah. Anyways, let's just make sure that I don't have any pending changes for Git real quickly, because I don't want to. It looks like I do. Yeah. And we don't need that temp.txt. Where is that? And what is that? Temp.txt is blank. Okay, well, we don't need that. We'll just do that. So now we should be, yeah, okay, cool. So we'll just do that and then say like bring up to date. And if GitHub is up, we'll say push feet add launcher. Don't know if you guys were affected by all those outages from GitHub like a week or two ago, but man, they were just down all the time. Yeah, let's see, just catching up on the chat. Yes, the blah world, it's amazing, I know. Girlfriend, need ambient occlusion. We got ambient occlusion. It's just not working correctly on custom blocks yet. Still got to work on that. And Vox Rift, it's definitely not around 80. You always use 120 for FOV whenever possible. Yeah, I got to work on that. And as he was, the color and lighting on that main menu screen was just, thank you. Yeah, I'll have to tell my brother because I really liked it too. He did a really good job on that. Okay, let's go to the camera first then. And we'll fix that default FOV because people don't like that. Actually, I think it might be in settings.cpp. Yeah. Okay, default FOV. There we go. Now nobody can complain. Please add sandwich. Okay, well, if we get this async thing working, we will add sandwich. Let's go to github.com because I have another branch and I was working on it, starting the async process, you know, getting it building properly and everything. I don't feel like merging that branch because it's just gonna break because I did a lot of changes. So instead what we're gonna do is we're just gonna kind of like pick the stuff out of there and then add it. So let's go to this one. I think it's model loader. So we'll go here and we will say compare and pull requests so that we can just see the changes. Okay, so I changed 270 files. What the heck? Doesn't sound right. Okay, so oh, I did change quite a bit in here, didn't I? Oof. Now I'm debating whether I want to actually do what I was thinking. I was just going to like go through here and pick out the changes and just add them back. But it looks like I've actually made quite a bit of changes, which isn't cool. Let's see what we got in here. So ideally what this should be, oh, I changed all this stuff. That's why there's so many files changed. Is this still, let me look. If we go into a H file, no, that's working right. Okay. What branch am I on? Wait a second. Now I'm getting confused. Okay, we are on feat add launcher, and this branch that I'm looking at is feat add. Oh, that's why. Okay. Never mind. It's all good, guys. Don't worry. Okay, let's go to this one. I want to see the changes I made here. How many files is this? This should be low. 6 files. Okay. Whew. That's much better. Cool. So this is all the async changes. We can just copy this stuff around. So in our Git modules, we will add this. Let's go to Git modules here. I got scared for a second there. I was like, this does not look right. Okay, so we're adding in async there. That's all good. And then I'm just going to delete this branch after we kind of steal all the changes. This was just a test to see if we could do stuff, and I may re-add that. This is the big piece of garbage, all the CMake options. So let's go ahead and add this. This is in our build.bat file. So let's go ahead into here. Yeah, I don't know why they don't just have a default, like turn off all the options, which is what I wanted. So I had to like go in there and just manually add all the different options, which wasn't very fun, but it is what it is. Okay, so I think that's right below. Let's check that out again. This is right above go to done. So it's right here. Okay, so this should go, and if async is not built, it builds it. I need to change my build system too because this is fragile and it just doesn't work all the right all the time, but that's for a future day. Get this. This should just get that. What is zlib static? Why do I have that imported here too? What is zlib? Now I don't. That's probably not what it is. C++. I wonder why I have it added here. That's weird. Oh wait, no, this is async. Oh, okay, never mind. It's because they need it. Okay, all good. Zlib is compression library. Okay, yeah. Sam, async no export. Async build all importers by default. Oh, well, I don't want to build all importers. I just want, you don't need to disable the exporters and importers. There's one option for that. Well, I don't want to build all importers by default. So I think that's the thing. And then async no export. That might work. I'll have to try that later. I will write a to-do in here. Let's do rem to-do. Check out async no export. And because I tried the options that they said should work and it wasn't working right. I was going through their docs and everything that they have on their GitHub, and they said that if you add another one, it shouldn't build the other projects, but it still was. So I just ended up doing that to make sure that it was working properly. I mean, this works, so I might not change it, but I might. I don't know. We'll see. Anyways, we need to go into our pre-make file as well and add those. Those were, let's see, on line 39. Let's go up there. So if we go to line 39 up here, right around here, yeah, this looks right. We'll add those, and that should be good. And then what else did we have to do? We had to add this on line 127, so add the include directories. That's probably changed by now. It looks like it is. Oh, wait, nope, looks good. Okay, cool. And clearly to do this is bad, so I need to fix some stuff. Okay, so that should be good. We only need async in the game. I don't need that in the engine yet. I might add that later. Okay, and then copying the built DLLs once they are built, which is line 191-ish. Let's see. I'm guessing that should actually be there. Yeah, wait, okay. So it says minus 169, then it says 191 there. I think their line numbers are just broken or something, because that sounds more right. Okay, anyways, I think that's probably correct, and then I just need to change this to just vendor. And, oh, and I need to modify the Git modules too, because I changed some file paths and stuff. So let's just go into here real quickly. This should be in... Okay, vendor. Okay, yeah, we'll just remove that Minecraft. It's just going to be in vendor/async. Okay, cool. So that should be good. And let me just make sure this is all correct. So, oh, why am I adding Lua here? Don't want to add Lua. Just async. Wait, do I? Was that something I had there? Yes, I don't want to add Lua. Okay, so let's remove that. Okay, so that's vendor async build bin cfg build. Okay, DLL PDB, and then we're putting it in the target directory DLL PDB. Okay, cool. So that should be good too. And I think we should be good with that. Let's go ahead. We're going to run build. Well, actually, we'll run git pull dash dash or git, what is it? Update dash dash recursive. I think that's it. Let's open up this thing too, because I like this more. Git submodule update dash dash recursive. Could be wrong on that. I don't know. Nope, that didn't work. Git pull. Well, that's fine. Dash dash recursive. Did I forget ini? Init? Do I need to init again after I add a new Git module? Did not know that. Submodule update dash dash recursive. Yeah, that's not here. Let's see. Git update new submodule. Oh, Git submodule in it. Okay. That's what I was missing. I'm guessing. I think that's what you were referring to. And then we'll try this, maybe? No. Vox Roast is saying dash dash in it. That's still not working right. At least I don't think it is. Let's check vendor. Yeah, there's no async in there. Let's see. Git pull new submodule in .git modules. Git submodule dot. Oh, okay, dash dash in it. So that's what you guys were saying. Gotcha. That makes sense. Oh, and you just did that too. Okay, there we go. I'm not a Git expert. I usually mess everything up with Git. Okay, did that work? Let's see. Vendor, no, we still don't have it. That's weird. Let's try what they were saying there, and we'll say vendor/assemp, which is where it should be. Vendor/assemp, yes, okay, that looks correct. You know what, let's just say screw it with this. I'm just gonna say, oh, is it because this is wrong too? Hopefully I didn't just screw everything up. Let's see if it, there's no Minecraft directory, so, oh, and I don't think that matters too, but yeah, okay, we're just gonna say screw it, and we're gonna do it this way. Git submodule add, let's see what that was. Okay, this to vendor/assemp, and then we will get rid of that, and that should do what we want. We'll be good that way. Yeah, I tried that command too. It wasn't working. No, so it's hard to do development in live. There's always a bunch of things that you're clearly not on your mind. Yep. If you're not solid, you can get lost in outsourced ideas. Yeah. Usually I'm okay with Git when it comes to other stuff. Sometimes, I don't know, there's always weird Git things that just pop up and I'm like, okay, this is annoying, but sometimes Git is a lifesaver. Cool, looks like that worked. Okay, we're good there. Sweet, so now that that's done, painful, I know. Let's go to here and we'll say build VS 2022. And let's go ahead and, okay. The source directory does not appear to contain cmakelist.txt. Did I do something wrong there? Oh, you know what? It's because I have, okay, I have that going to Minecraft. So, like I said, I had changed a lot of paths and stuff, which is why I didn't want to merge. So let's go back into here. And this is, yeah, we just need to remove that, that, and that. And I believe we should be good that way. Yep, those are all just options. So we should be good now. And let's go ahead and run that again. And I think this should work now. Okay, cool. So it does look like it's building it. And let's see if I zoom this in a little bit so you guys can see it too. It says enabled exporter for Aspen. And they said, why did we name it the way we did and stuff? And it's because they're German or something. So English isn't their native language. So for all you native English speakers there, that's why it's kind of funny names. Anyways, and then disabled exporter formats are all that stuff. Do they have enabled importer formats? Okay, here we go. And then FBX is the only one. Yeah. So this is basically, I need to do an exporter. Oh yeah, I need to import Aspen too. So basically we're just going to use these two formats, which is why they're the only ones I have listed. So that all works out. And now if we go into main, and we'll do something similar to what I did here just to test this again. If we go and add this is just like a basic thing, and we'll add that first. So we'll do this just to play around with the library because I want to get a feel for how it works, and then we can sort of begin adding and everything. Okay, one or more projects in the solution were not loaded correctly. What's up? Okay, not found, not found. Do I have the paths wrong? I think I have the paths wrong again. Same thing as before. Yep, so that should be vendor and vendor. Cool. So let's go rebuild that. And now we should be good. Let's see. All right. And does it work? Okay, looks like it works. Did we get it added up here? Yes, Assemp is up there. Sweet. So last thing that we're going to do to make sure that this did all import correctly, let's go into, is this? No, this is not the main I want. Let's go into here. And then let's also go ahead and say close all tools, all but this. Okay, cool. So we got this. Let's add that. That should be fine because looks like it's not fine. So I did mess something up. Let's go ahead. We'll add this. Am I in the right main too? Yes. Crumble. Okay, yeah. Cool. So then we need to go and we'll do this. That. And I'll just return, clear all that stuff out. Okay, so let's fix those errors, which I think I just put the include directories in the wrong project, maybe. So that's project crumble. Nope, looks like it's because these are wrong. Once again, I changed all those paths and I'm throwing myself off now, but I didn't want everything to be Minecraft. I wanted it to be crumble, which you can see here. So important change, but means I keep forgetting which paths are correct. Okay. Reload all. We should be good now. Hopefully. Plus the copy libs. Did I not fix the copy libs too? I think I did fix the copy libs. Okay, yeah, I did fix the copy libs. That was the only one that I did fix because this is going to vendor. But yeah. You forgot to change the paths for the copy and pre-make. Yeah, that was it, I think. So I think we should be good if we run this now. Yeah, I know I forgot everything else, but if we run this now, I think it should build ASIMP if needed. I don't see it building ASIMP, so that's kind of concerning. And you guys can't really see because of this, the chat and everything is in the way. I might need to move the chat because it's kind of in the way of stuff. Maybe I'll move myself to the top right corner, like my video here, and then have the chat down here, just so that it's not in the way of things. But I don't know. Future stuff. This isn't going to work though, because I don't think I even have testmodel.fbx. So yeah, move us carefully, please. I got you. Don't worry. I'll do that next stream so that we don't interrupt anything here. Just got to remember now, which is the hard part. While we're waiting for that to compile, let's go ahead and take a look. First of all, just take this back out of here. So this is going to be in assets. It looks like I was storing it in /models/that. And I just closed everything. That's fun. Okay, let's pull that up. I got to pull everything back up. Yeah, Windows does that. Whenever you start shaking something around, it like minimizes everything, which is super annoying. But yeah. Can the chat, maybe if the chat box was more translucent? Yeah, I might try that out too. We'll see. And Blink's Play Dirty. Hey, didn't know you streamed. Love your videos. Thanks. Yeah, good to see you. And streaming is kind of rare compared to everything else, but yeah. Do I need to build this manually? Yeah, it looks like I need to get the dependencies set up properly because that was not built. So we'll have to take a look at that. But anyways, as I was saying, I think I need a models folder in here. And what we're going to do is, looks like we will kind of categorize everything throughout here. My mic keeps like falling down a little bit. There we go. Okay, so then if we were to run this again, we should, no, still doesn't like it. So copy vendor, free type, release. Oh, this is for free type. Why is... Oh, no, it's not. It's for this. Okay, let's see. Vendor, ASIMP, build, bin, release, that. Let's see if that file exists. So if we go to bin, or I guess if we go to ASIMP, sorry, vendor, ASIMP, build, bin, release. Yeah, that looks like it exists. Okay. Huh. I'm trying to think of why this command might be failing. I hate how Windows, because like it just tells you exit with code 1 and does not tell you anything about why the command actually failed, like which files are broken. But that looks fine. This is vc143-mt.dll. Oh, it should be mtd. Okay, we have the wrong runtime for some reason with ASIMP. That's weird. I'm just going to go modify it manually, and I'll have to put a to-do or something somewhere. So it looks like we're using the wrong runtime here, which... Okay, dynamic library, that's good. Does it have, I think if we just look in here, or maybe all options, runtime. Okay. It says it's using /md, but it's building -mt. Weird. Oh, wait, no, -mtd would be multi-threaded debug, which we don't want in release. So if I switch to debug, I have a feeling this will work. Now we get another long compilation time, so we'll wait a second for that to compile, and we'll have to recompile async too. Voxers, I believe that's a C runtime thing, not a Windows thing. Yeah, the no errors part, yep. Nelfs, is using C++ outside of Visual Studio painful? I've never used it outside. Yeah, it's not that bad. Visual Studio is super nice because of the debugging utilities, at least I think. Don't know what other people think, but I really like it. I know some people in the server prefer CLion. Sam really likes that one, so if you want to go that way and try it out, it's good. I think you need to use CMake if you do go that route, though. Not completely sure. But yeah, it's usually not that bad. Debugging is the worst part, trying to figure that stuff out. Yep. Kirk IXXX. I'm not sure how to pronounce that. You certainly prefer CLion as well. Okay, cool. Yeah, Sam, don't use Visual Studio, but CLion, and you use CMake for building. CLion is paid, but I think you can get it free if you're a student or something. And Voxer is 4-coder. Yeah, so you can use whatever you want. Like, you don't have to use anything specific, but like I said, I do prefer Visual Studio's debugging utilities and stuff, and it's what I'm most comfortable with, so I stick with it. Yeah, student license, you can get stuff for free. See, and this is free too. Visual Studio, I don't have to pay for anything. It does have some pretty crappy refactoring tools, which I'm pretty sure CLion has better because they're the developers. JetBrains develops ReSharper, which is like the plugin for Visual Studio to make C++ development easier. So, yeah. Use Visual Studio for debugging. Unfortunately, its performance is disgusting. VS22 has felt better to me, but I'm not completely sure. And Fleet will have support. How are you seeing this? I haven't looked too much into Fleet, so some other people may have more input on that than me. But yeah. Am I familiar with After Effects? Like Photoshop After Effects or whatever, I am, but I was going to use a bunch of Adobe products and then completely decided not to once I started using, what's it called? Premiere Pro. And I was just like, it's just so gross compared to DaVinci Resolve, which is what I usually use, and it's free. And Photoshop or Adobe product was so gross that it made me not only uninstall it, but then I paid for the Pro subscription for Premiere or for DaVinci Resolve because I was like, okay, I really like this product. I'd rather support them. But yeah, have not used After Effects though, if that's what you're referring to, which is what I assume. But yeah. Okay, cannot open file ./contrib/zlib/debug/zlib static.lib. What's going on there? So we got bin debug. We got nothing in debug. Why is it not doing that stuff? Do we have extra steps in our build.bat? Oh, you know what it is? I remember this now. This was the stuff I was supposed to add to these files, but I forgot to because I just got it working and then ignored it. Yeah, so there's a bunch of weird stuff with Asimp. Like, it builds this debug folder. So if we go into build, yeah, if we go into here, it builds a file. Where is it? It is in contrib. Yeah, so if we go into contrib zlib, there's something in here. What is it? zlib static d.lib. Well, it doesn't look like it's there. Oh, no, what it is I think I need to build zlib first. Okay, let's build this. Why do you not want to build this Visual Studio? Array is too large. That's not. The operation could not be completed. Unspecified error. Oh, that's great. This is why C++ annoys me. Getting any sort of projects working is just super annoying. Games with Gabe. If you use CMake, you would not need to resolve these types of problems. I did use CMake, and it still has these problems. So I build the project files with CMake, which should just work, and then it doesn't. So I think their CMake script just doesn't support Visual Studio very easily. I don't know. It's saying zlib static is not working. And C++ aside anyways, it shouldn't be this difficult to do development or import libraries on C++, period. Like, they just need to get their crap together. I just hate everything about it. Okay, so it says external project is vendor/asm/build contrib zlib. Is that correct? Vendor asm build contrib zlib. That looks correct. And then if we open up this guy, just make sure that we have the right ID in here, which is this. It shouldn't change, but I don't know because it's not working. Yeah, so that's wrong. Okay, I thought these were stable, but I guess not. Okay, so if we look for zlib static, I guess we need that, and we'll replace that. And then if we go and rebuild one more time, fingers crossed, we should be good. Okay, that's that. We reload. Now we should be able to build this. Okay, so now that built, we're good. Build this. That built, we're good. Okay, run this. And not quite, almost there. Okay, unresolved external symbol, reference and function main. Did it not copy the files for some reason? Let's check and see. Bin, we're in debug, crumble. No, we got the files here. Okay, so that's good. So why are we getting unresolved external symbol? Was there something else I have to do? It looks like the .lib file is not linked properly. Oh, did I forget to link it? I think you're right. Thank you, Sam. I don't know how I missed that, though. Links, GLFW, free type pthread. Okay, that's Linux, though. I think. Where is my linking stuff? Okay, so include. Okay, links. I think if I just do that, it should work, and that should. Did I name that right? I just need to make sure. zlib static asm. Okay, yeah. I think that's all I need to do, and it should just figure everything out. Maybe that's why it wasn't building properly, too. So let's do that. And with any luck, we're good now. Ah, thank you. Okay, that was it. Cool. So it worked. It may not look like anything happened, but it did work. Basically, what I was trying to do here was just like inspect stuff. What we're going to get is this doesn't even work. So if we look at scene, it's null because this model does not exist. Okay, finally. We're there, guys. Now we can start building models and start looking at stuff. Yeah. Unresolved externals always means leaking errors. Yeah, I know. It's still annoying, and I always get confused by it, even though I should know at this point what it means. But good to have you guys here to help me out for this, though. Okay, so let's go assets, models. Let's also open up Blender. And we'll create a cube, and then what I want to do is kind of like figure out how we're going to import this stuff. So we've got our cube here, which is great, and I'm literally just going to export this as is for now. Let's go, first of all, and we'll put this inside of right there. Okay, we'll put it in here. And we'll call this models.blend, and we'll say save Blender file. Okay, cool. So we got that saved, and then what we can do is, I think if we just do export, and then we can say FBX. Cool. So we'll do this, and we'll call this cube. Cube.fbx, and then we will see what this gives us, and we'll go from there. So we'll say export. Just make sure everything's correct. Include selected objects. I don't want the whole scene, just the object that we have. So that would just be the mesh is what I want, because I don't really care about everything else. Okay. Animations are going to be something else, though. Once we get to that, we will have to do more stuff. Sam, in my opinion, the FBX format is best for importing models in game because you can embed animations and textures inside. Yeah, that's why I'm using FBX. Because I wanted to add animations and stuff as well. I think I'm eventually going to switch to the ASIMP export, though, which I believe should allow us to like export in a binary format and still import all the animation data and everything. And now sandwich time. Okay, if we get this working, I am building a sandwich, and we're going to have a sandwich in the game, okay? So let's hope we get this working pretty quick, because I want it to work, and that would be cool. Minecraft sandwich, never been seen before, right? Okay, so if we do that, do we get a scene? Okay, so we do get a scene. Let's explore this a little bit and see what is in here. I want you guys to be able to see what I'm doing. So it looks like we are going to be moving some stuff around. All right, I'm moving the stream around, guys, and then you can tell me if this is bad or good, and we can switch it some other time. For now, though, let's go ahead and just... Whoops, not mean to do that. Okay, you guys aren't going to see this too until I actually do it. Wait, I just got to select everything over here. Do that. Whoops, not that. Oh, come on. Okay, let's see if I can get this. So that. And that. Okay, move all that stuff over there, and then I moved one thing that I shouldn't have, which is that. Can I move it back? Properties. I would show you this, but then we'd go into Inception. I don't want that. Let's see. Can I move this back? No? Yes? I moved something off the screen, and I guess Streamlabs does not give you the ability to move it back onto the screen, which is really stupid if you ask me. Oh, here we go. Transform, reset. Okay, there we go. So we'll do that. Make it smaller. And smaller. That's good. Cool. So I think this should be good. All right, I'm in a different place. Everything should look different for you guys, and now you should be able to see down here, which is the end goal. That's what I wanted. So we're all good. Cool. What's the chat? Sandwich. Yes, everyone wants a sandwich. Good, because I do too now. Next video, devlog. We got the sandwich. It will be there. Don't worry. Okay, so if we go to locals, we can see this thing here. And let me know if this is big enough for you. I don't know if I can zoom it in anymore. Let's see. No, it looks like it just zooms that in. So I can't actually zoom this text in for you guys, which I apologize about, but hopefully you can sort of see it at least. So I don't think I want that. Let's look at the scene. So the scene, and I guess we can look at ASIMP's actual documentation and stuff. We basically get number of meshes, which is 1, which is what we would expect. The root node, which I guess is like animation data. At least that's what I'm assuming. And then we get this M meshes, and if we look, we can see we get 20 primitives, 24 vertices, which is correct. If you think about it, a cube only has 8 unique vertices, but root node is the scene root. Okay, thank you. Yeah, I'm going to have to look more into this stuff at the future, so don't listen to what I'm going to say as like gospel. I don't think what I'm going to be saying is correct. It's what I'm assuming, and I'll look at the docs later on to figure this stuff out. So yeah, just a disclaimer. Anyways, I know nothing about this stuff, so this is all just like me winging it. Vertices make sense, right? A cube has 8 unique vertices, but we have 6 faces. We have 4 vertices per face, and we have different normals on each face. So we're going to get 24. 6 times 4 is 24. Primitive types, 20. I'm not sure what that is. Maybe that's like triangles, number of triangles or something. Not sure. And SamCheck, if you want to check working loader, I can send you a link to my CPP. Might check it out later. I just want to kind of go for now and see what I come up with, and then I will change it up as I learn. I like doing things first on my own just so that I can get a feel for it. And sometimes if you know a solution, it biases you towards that solution instead of any other possible things. So vertices though. So we get the vertices, which is a pointer. Yep. So it's just a pointer. Does it tell us? And it tells us how many there are. So what we could do is we could like see each one, and we get the normals associated with those, which is good. Tangents, bitangents. So those are things for like lighting calculations, colors, texture chords. Okay, cool. So we get all this stuff, which is great. And these are all null, which I guess that kind of makes sense because we don't actually have texture chords. Or actually, I don't know. I think these are like different things. We'll see eventually. Okay, and then we even get the faces. We get the bones, which there are none because we don't have animation data. Cool, and it even gives us an ABB. Does this actually work? I don't think this works because that's not a proper bounding box. It's just 0. If we could get that to work, though, that might be cool. Because then I could automatically like detect bounding boxes and stuff, too, which is something we will need. So that's something to think about. But yeah, so we got this number of vertices. Let's think how we can use this data. We got number of vertices and we have normals. So I've talked on past streams and stuff about how I'm importing this data into our shaders, which if we take a look, they're pretty messy. I've got to clean them up and stuff. But basically, we have everything compressed into this binary format, right? And so what we essentially have is we have unique vertex offsets, which are like offsets from 0, 0. And we store these in a texture. Let's go to the drawing screen because I think this is going to make more sense over there. So let's go over here. So basically what we have is if I pull up a drawing, say we have like a square, right? So what I end up doing is I store these vertices in a texture, which is just an array. So let's call that V0, V1, V2, V3. So then what I do is I would store these. We'd have V0, V1, V2, V3, dot, 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 and the rest of these. And then what I have is I have the triangles. So like each index. So I have another texture. Do I? No, this is on the CPU side. So on the CPU side, I have an array which is full of the triangle indices. So this basically goes and points into this thing, and it finds the global vertex inside this vertex offset. These are all unique, and it basically says, okay, let's go through and we'll say triangle 1 is V0, 1, 3. So that would be like 0, 1, 3. So basically elements, right? It's the same thing as you would do in OpenGL, 0, 3, 2. And then this would be like our cube. I'm not going to erase that. So this would be like our cube or whatever. In this case, it's our square. And so this is all stored in some element called a cube, which gives us sort of the model data so that we know how to build it. And then once I go in the chunk, I go through this, I go and look up into this index, which gives me the appropriate vertex offset. All that stuff works out so I can figure out different things. So yeah. Oh, an AI process gen bounding boxes. Cool. Thanks, Sam. Let me put a to-do in my code too, because that will be cool. So that's kind of how it works, if that makes sense at all. And I'm thinking out loud here because I'm not sure how I want to do this. We're just winging it, and we're going to see what happens. Let's go to do AI process gen bounding boxes. Actually, I'll just throw that in there. And that's cool. Sweet. Okay. So if we take a look at our data structures, we want to fill out these data structures. Let's go into, I think it's, no, I can't remember where my stuff is. It's been a long time since I've been in this code. Include, I want to say this is in utils, but I don't think it is. World? Oh yeah, block map. Okay. So if we go into blockmap.h, I think this is it. It might not be. Yeah, we've got our block types up here. We've got block format. That's something different. Texture format, condition, rotation rule. Okay, this is it. Yeah. So this is how we're storing it. So basically what we need to do is we need to get the vertices. We need to get the face indices. Okay, so this is the part that I need. So basically what I'm doing is for each face, I have like back face, and then it has like elements. So it would be like back face is those vertices, and then like front face is vertices like 2, 3, 4, 2, 3, 6, or whatever, right? Or 5. So we basically have 6 arrays, as we can see here, and they point to what the vertices are. So what we need to do is, as we're looping through this data, we need to look at the normals, and then whichever normal is it's closest to, that's the face that I'm going to say it is. So if we have a normal that's like 0, 0, 1, clearly that is the Z forward axis. This is Z forward, which in our case is right. I messed up my axes. So Z is right, left, X is front, back, which makes absolutely no sense, but that's the way it is. And then what we'll do is we'll say like if it's 0.1, 0.05 or 2, and then like 0.8, we will also call that Z forward. Now clearly it's not actually Z forward, but we're just going to do like the closest kind of thing. And I'm going to have to see how angles work with this and stuff, like angled blocks, because we may or may not actually have angled blocks allowed. I don't know. We'll have to think about this stuff. But yeah. So basically what we need to do is we need to go through this data, which we get scene, let's see, get meshes. Yeah, okay, cool. So we can sort of loop through this. So we can say for int I equals 0. And actually what we want to do is we'll just say glog or assert for now, and then we can add support for this later. Scene m number meshes equals 1, only 1 mesh per model supported. And you know, in the future I'll add more support to like figure out what to do when you have more than 1 mesh and stuff. Kirkix importing 3D models, is this for mobs and such? Mobs and such, but also for blocks, because the way blocks work are, I have this file, and this is really annoying, so I just want to change this. We have this file which is called block formats. No, not that one. Block vertices. Yeah. So I have this file called block vertices, and this is basically how you define a new block. So like I have a cube, we define all the vertices, then we define all the face indices, which is kind of what I was talking about there. And then we have stairs and this. So yeah, this is how it goes. It's just really annoying to add all this stuff. I have this rules thing, which I think I'm going to keep. But these vertices and stuff we can generate, and that's what I want to do. So what we're going to do is we're going to generate a file that looks like this. And then we will re-import it. I'm debating if I even want to generate the file, because I could just load directly from an FBX. And we can do this, which is what I think we may do. So yeah, let's do that. Okay, so we will see if we have that number of meshes. I'm going to do everything in main for now too, and we're just going to kind of wing it, see how it goes, and then all that stuff. So then once we do, we will say const AI mesh. I'm assuming that's what it's called, star mesh. We'll see. Equals scene m meshes 0, which we should have guaranteed because we have one element. So that will be our mesh, and then we can say mesh m number vertices. Cool. So we'll say for int vert index equals 0 until vert index is less than mesh m number vertices vert index plus plus. Okay, so we'll loop through all those vertices, and we basically want to get a group of vertices and stuff. Let's go into, this is what we want to fill out. So this is our goal. We want to fill out this structure. Let's copy that. We want to say, paste that. This is what we're trying to fill out, and we'll go through that. Oh, and I need to remove these things too. We don't need that. Okay. Let's go into blockmap.cpp. And the code that is currently loading this stuff is very ugly, so don't pay too much attention to it. I'm expecting to change a lot of stuff too. I have like a whole mini parser in here for this stuff, but it's probably going to change quite dramatically because I just need to do some other stuff. And I have it wrapped in a try-catch because the YAML library that I'm using uses try-catch to display rules, which is kind of annoying, but that's, or exceptions, I guess I should say. But yeah. So let's just look real quickly though. I want to see what I do. So this is the X offset. Okay, so we loop through each vertex, and then what we do is we say, we get all the block vertices. Yeah, so this is what we've got, like a one global array. Yes. See, this is where it gets tricky. Let's do this. We're going to say, copy this, paste, and then we can do this. Const char star models directory. Okay. So my goal, what is my goal? Repeating this for you guys as much for myself. What I'm going to try and do is we're basically going to have like a YAML file, which consists of this, and then we can say like model file. And this will say cube.fbx. Okay. So that, the reason I'm keeping the YAML file is because I have these block rules things. So this stuff, which is for like corner stairs and everything, which basically tells how to rotate it. If this block is facing one direction, the other block is facing another direction. That's all going to get removed, hopefully, at some time. But for now, we're going to keep it just because we have to. So instead of all this stuff, we're going to comment this out too. We're going to say model file is stairs.fbx. And I don't have a stairs.fbx yet, so we're going to wait on that one. We'll just leave this as is. So let's try cube first. Cube is pretty easy, right? No. Come on. I want to uncomment Visual Studio. Is it that difficult? It shouldn't be. Okay, let's go ahead. We will get rid of that. Okay, cool. So let's go. This should be pretty easy. So what's going to happen is we're going to look through the models directory, which we have here, and it has this cube.fbx, and it's going to search for this file inside of this directory, which gets passed in right here. Okay, so we're going to search through that directory for that file, and then if that file exists, we'll go through. Otherwise, will default to the regular thing we were doing, which was this thingy. Yes. For now. That's what we'll do. And then we'll change it once I deprecate all of these things. We'll remove it. Okay. Hopefully that makes sense. I don't know. We'll go with it. Yeah, you can even see in here I have a reminder to myself. Z is left to right because I keep forgetting that the Z axis is left and right because that's stupid. And I don't know why I made it that way. Okay, so we've got cube.fbx. We want to get those vertices. Actually, I probably should have left those. Wait, what did I just do? No, not that. Okay, so we want to get v0, v1. We want to get something like that, and then we want to get something like that. Cool. So let's grab this, and we will go ahead and say, put that there, and we'll put this somewhere down there, and we will go ahead and just add these to core.h. And is this the right one? It is. Okay. And then I will just say that's asm. Okay. So we got all that sorted out. Let's go ahead. That should be fine now. Cool, it is. We need this, which I lost, and we're gonna need that stuff. Okay, which is what we'll get to. We'll do this, comment it out for now, reference, and then we're gonna grab this, and we'll get rid of that. And let's go ahead and do that, and I might copy this comment block too, so we have that for reference as well. So reference, okay, and then reference right there. Okay, cool. So we've got all of our reference material stuff, which is good. Just kind of tab that out so I can see it a little bit better. Cool. So now let's go and we will go ahead and try and work this all out. And is FBX similar to OBJ? It's kind of the same. I believe it's in a more compressed format though, and then it's also, it includes animation data, kind of like Sam was saying earlier, which is good because I eventually want to support animations and stuff for mobs using the same kind of techniques. So yeah. Okay, so we've got this thingy. We need to go ahead and say, okay, so we get this block vertices thing, which is this thing. Oh, and then we go through each block type dot length. Okay, cool. So this is like my initialization thing. I'm just initializing all of them there. And then we just push back. Okay, cool. So that's the first thing. Yeah, no problem. Oh, and Sam's info too. Yes. Okay. So the reason that I have this thing here is because this is initializing all the structures. If we go up to here, you can see we have a vector of block vertices. And we have how many block vertices? We have this many. Cube. Nope, not cube face. Where is it? I've lost it. It's in here. We have block type. There we go. So we have this many kind of things. So for each one of these, we just index directly into an array, which gives us like the model. So that's kind of what we're doing here. This enum doubles as a index into that array, which is here. So if we were to say like all block vertices cube, and then this you can see is 1, then that will take us directly to the cube model stuff. And that's the whole point of this. So what we do here is we initialize all that stuff, and then we begin looping through all the block vertices config, which is this file. So then now in this loop, what we're doing is we're here. We are seeing cube. And what we want to do is we want to see if there's a model file. If there's a model file, that's what we're going to use for that thing. So then you can see I get the block type. And what I'm doing here is I'm saying if vertices is not defined, we throw an error. But instead of doing that, what we're going to do is we're going to look for that model file. So what we'll do is we'll say if not block vertices config dot second model file dot is defined glogger error no vertices or model file found for block %s skipping loading of this block type. Okay. And that str gives us that. Okay, cool. So we will only continue if we don't have vertices or block vertices. But if we do have the model file, we'll say else. Let's do this. We'll say bool load from model file was false. And then we'll say load from model file equals true. Okay, and so then what we'll do is this is all the loading stuff that's if we're not loading from a model file, and we'll have all the other stuff for that. So basically this I can just sort of abstract away. Yes, I think. Right here? Maybe. No, I think it's like right here somewhere. Let's do Control KD. Cool. So automatic indentation saves my life. So yes. Okay, cool. And then we'll say like to do deprecate this. Okay, so if we're not loading from a model file, we'll go through with the regular loading routines for the vertices though, and that's where I want. So basically what we do is we get the block type here. This is common, so I do want to keep this outside of the loop. So now I'm going to pull out all the common logic that's going to be shared between both of these techniques. So we need to get the block type, which is basically converting this. So this string gets matched up to the enum that we have in here. So cube goes to cube, and that's what's happening here is we're finding out which enumeration it matches. So then that would give us like 1. So now we have the block type as a code typed variable instead of just a string, which is good. And then if we don't find that, we say unknown block type, we print out what we got, and then we just say continuing. So that way you kind of know what's going wrong. Okay. Then we get the number of vertices. So this is the part that's going to differ. So this is going from vertices.size. I started throwing these things in here too for all user input stuff, which I think I'm going to continue to do. So basically, I'm expecting this to never be bigger than int32. And so I make sure that's true. And otherwise I say integer overflow. Not sure if this is like common practice or not. I don't know if I'm going to keep doing it, but maybe. Who knows? Okay. Anyways, this is where we differ. So we go, this gets the block vertices. This gets the number of vertices, global index vertices, lots of vertices. And then this goes through, it parses it. And then it gets the indices. Okay. This is all part of that stuff too. Okay. And then we get the rules. This is stuff that's different. So then, whoops, that's not what I want to do. Else there, that, and we'll say Control KD. Okay, so then this will go through the rules. Okay, and we need those block vertices apparently. Yes, so we will grab that because that is common to these things. So we'll say that, which is good. Okay, cool. And Hilbert curve, how does magic enum work? Like, how can it convert an int to a string? It's not converting an int to a string. I think it does some macro magic that I just did not want to do. It's a very cool library, though. It's like a single header file and stuff, too. Single header library and stuff. But if we look at it, I think we can just check it out. Where is magic enum? Somewhere in here. Oh, it's right here. Magic enum. So if we look at enum name, oh no, it's using templates, which is also cool. So it says enum name e value, which is getting from the templated parameter. Detail enable if enum t e string view. So it stores it in this names v thing, which it's doing some more magic, I'm guessing, to figure out what exactly that is. Okay, so that's going into type traits. I'm not really sure how this is working. I assumed it was like macro magic, but it looks like it's using templates to do this. So that's pretty cool. I wonder if this enable if enum t. Let's check that out because now I'm interested. C++. Oh, that's just checking to see if it's an enum. So that says if it's an enum, then we can do this. Stood decay t. I'm guessing that's how it figures it out. Whatever decay does. I don't know. But yeah, it uses template magic, I guess. And then what it does is it just converts it to like a actual string. And then what I'm doing is I'm just going through and then matching that string. So if the string matches whatever this block type is. So if we get cube equals cube, then I know it's a cube. And then I just say block type equals current block type, which we can get from our index, which is just looping through all the enumerations. But yeah, it's cool stuff though. You should definitely check it out. Okay, so we've got our block vertices here. Get the block vertices. Redundant comment if I ever saw one, but I'm keeping it there because I want to separate this. Okay. If we're not loading it from the file, this is how we're going to get the vertices. Otherwise, if we are loading it from a file, how do we get our vertices? Well, we get it a different way. And let's go ahead, copy this for reference so that we can sort of do the same steps, except we will change it to be another way. Okay, so we do that. And then right here, what we're going to say is number of vertices. How many do we have? Well, we have as many as async tells us. And what is async going to tell us? Well, it's going to tell us that we have this model file. So if we have this model file, we will try and load it. Okay, so let's copy that. Go right down here. Okay, we'll say stood string model file equals that. I think I'd say as stood string. Yeah, and we may as well remove it because I think that creates a copy anyway, so it doesn't really matter. Who cares? Okay, so we got this model file, which we're getting from the config. So now this is going to be cube.fbx, right? That's what we should have in there. So then what we're going to do is we passed in our models directory. So theoretically, that models directory should have our models file or whatever. So if we say stood string model file full path equals models directory plus model file. And C++ will auto convert this const char start to a stood string or do whatever it does to make sure that this gets concatenated correctly. Okay, so now we have the full path. We want to make sure that it exists. So we can say if not file is file model file full path. We can say logger error. Always log good errors. Never put off error handling because it will save your life and it helps so much. Yeah. So we'll say glogger error model file for block type not found, and we'll say model file %s for block type %s not found. Skipping loading of block type %s. Okay, and then what we'll do is we'll say model file is model file full path because we want to see the full path if that's going bad. Block type is block type string.cstring. .cstring. Okay. And then we'll say continue. So if we do not have it, we kind of error out and then we just skip loading that block type. That way we know if we found it. Otherwise, this is a file and we do have it. So now we can begin importing, which we have here. So now we grab this. It's all working out, guys. We're almost there. Okay, so now we grab this. And let's go ahead and uncomment that. Cool. So now we're getting our scene, which is this. We read the file. And I should have copied that loop that I had to. Yeah, we also want this thing too now. So let's grab that as well. Put it right here. Okay, let's go ahead and tab that out. And we'll go here and that. Okay, so then we do this assert. Maybe we shouldn't assert since we're just erroring like this. So what we can do is we can say if does not equal 1, and then we will do brackets, close brackets, glogger error, skipping loading of block type %s, and let's also, once again, make your errors descriptive and add all the information you could ever want from it, because I hate it when I have a stupid library that's like failed. That's it. That's all you get. No, tell me why it failed. So only one mesh per model supported, found %d number of meshes. So we will print all the information, and that will be scene m number meshes, and then block type string.c string. And I'm guessing we also need to free that scene now. So importer.free scene, and then we'll say continue. Okay, and what's this saying? Too many arguments. How is that too many arguments? Oh, do we need to do a new importer per scene? Or does it matter? I'm gonna assume it doesn't matter and I can keep reusing the same object as long as I free it afterwards. We'll see if that's true. Okay. So this should get us all of our meshes, and we now know that we have one mesh. We can use that one mesh here, and now we're going to loop through the vertices. Actually, we're going to first do this, and this is going to be mesh number of vertices. Okay, cool. So now we have that. We'll do this. Keep that stuff, I guess. Okay, and then we will also do this, because now we're basically going in and translating this code now to use this file instead. Sam check. You don't need to free it when you have importer as local object, since the destructor will destroy last imported scene. Okay, we'll do that then. We'll do it our C++ way, which is the way I probably should be using it. So let's go back down to here. Nope, down a little bit more. Okay, right here. So we'll declare this in this scope, and that should mean that even if we don't do this, we should be good, should free it. Only if you would have the importer public would you need to free it. Gotcha. So if I leave it like this, where I basically declare it in this scope, then it should automatically free it once we go through here and exit that scope. I'll wait on you, but I am assuming that's what you mean. Yep, okay, cool. Sweet. So we've done this. We make sure that we have the correct number of vertices. And then we assign that to our block structure that we're starting. We get the global index start, which is just some metadata that I use for other things. We allocate the memory, which is what I'm doing here. This may be error prone. To do glum vec3 should not be allocated with malloc. I don't think it's a problem because glum vec3 is standard layout, but that could have problems elsewhere. So I might have to look into that. Okay, anyways though. So what do we do next? We do this thing, which is where we get the X offset, Y offset, Z offset, and then we do this thing. So instead of doing that, we can change this up. We can say X offset equals mesh vertices vertindex.x. Okay, cool. So this is basically what we can do now. Get rid of all that parsing stuff that was just like error checking to make sure it's proper values. Same thing here. Mesh vertices. See, and this is just much nicer code too. So I much prefer not to have to deal with error handling when I'm parsing stuff like this, and let a library do it for me. Okay, vertices vertindex.z. All right. And then we construct a vector using that. I could probably do something else if I wanted to. It really doesn't matter too much to me. So what were we doing here? We were doing int I, and then I was just the vertex index. Okay, yeah. So that's fine. We can, instead of doing that, say vertindex and get rid of that, and we're good. So that's the first piece of code translated. And now we need to do the indices. This is where it can get a little bit trickier. And I'm going to do this in an inefficient way. I don't care, because we're just making stuff work for now. I'll put it to do. Because basically what we're going to do is we're going to loop through every single vert index, every single set of vertices for each face. So that means we'll be doing it 6 times when we could technically just do it once, like here. Actually, yeah, so let's do our counts here. Yeah, I'm thinking about this a little bit more. We can do this a bit smarter. Ah, okay, cool. So we got this thing, which is the face indices length. So for each face of the, our axes, which is where we kind of decide what texture to apply to a cube or whatever, we got 6 faces, right? And inside the structure, we have this thing called face indices lengths, which contains the lengths for each face. Now, what I want to do is I want to figure out which face our vertex is closest to using the normal, surface normal. And then what we can do is we can just like increment this face for that vertex. If that makes sense. Hopefully it makes sense. If not, hopefully the code will make a little bit more sense. So we'll do like int block type, not block type, face direction, cube face. That's what it is. Okay. So we'll say back equals 0. We want to just initialize all this stuff to 0. I think I do that anyways. Let me just double check, because I think I do that anyways when we're doing our initialization step up here. Let's see. We do face indices lengths equals 0. Okay, cool. So we do that. Sweet. So where was that? No, it's up here. Okay, cool. So this is already initialized to 0. So what we're going to do then is we're going to say for each normal, or does each, I'm assuming the normals will equal the length of the array for our vertices. So like mesh mnum vertices should equal mesh mnum normals. M normals? Vertex normals. The array contains normalized vectors, null pointer if not present. The array is mnum vertices in size. Sweet. See, this is what I'm talking about. That's good documentation, okay? I should be able to do this, have this pop up, and just see exactly what I'm assuming, and that assumption is correct. So we can safely say that if mesh m normals, which I guess we're going to do this check outside because we need the normals as well, and if we don't have normals, we want to exit early. So if m normals, or I guess if the mesh, so let's actually, we'll get the mesh, and we'll say if mesh m normals, if it's not exist, we will error out and skip this because we need normals. No normals found on mesh in file for block type. That, and what we want to do is give it our file, which is Model file full path. We'll just do the model file here because we don't need the full path. We just need to kind of know what it is, and then block type C string. Cool. Okay, so now we know that we have normals. Those are definitely there. So what we can do, and we also know that if we do mesh m normals, it is guaranteed to be the same size as the vertex array. So we have the same number of vertices, so we should never hit an index out of bounds. Yeah. You don't need to free it when you have importer as local object, since destructor will destroy last imported scene. Oh, wait, okay. You also need to read the face indices from the AI mesh. You can generate normals with AI process gen normals. Oh, cool. So you can even generate the normals. I think I might have that actually. Cool. Sweet. Okay, so we'll use that, which I guess will generate them if they don't exist. And we need the face normals is what you're saying. I don't think we do, because I do want to look at vertex normals. I'm not looking at face normals here because I'm going to assume that this face normal is just the direction I'm using, which, yeah, we'll look at this later. I'll put it to do. Oh, face indices. Well, yeah, that's what I'm doing. So I'm basically going to generate. Oh, wait, you're right. Yeah, I see what you're saying. I think what we're going to do is when we go through the face indices, you cannot generate the indices. Okay. Yeah, we'll get to that when we get to that. Yeah. You need to read them from the mesh. Okay. Well, yeah, I'm going to read them from the mesh, and then we're going to shove it into one of these buckets, depending on which face it's closest to. So we'll get to that when we get to that in a minute. First, let's continue here. So block vertices dot vertices, and then what we need to do is, what was I doing? Oh, we need to count is what I'm doing here for our indices. So we can't really do that in here. Let's do, okay, I'm going to need to use the face indices like you're saying, yeah. Let's do face index equals 0. Face index is less than mesh. Face is, yeah, we'll do that. Number of faces. Okay, why are you not auto-completing Visual Studio? That's very annoying. Okay, mesh, faces, face index. What do we have here? We have indices. We have number of indices. Cool. Do we have like a mesh face normals? How do we know what normals correspond with which faces? So faces, face index, dot. We've got indices and we got number indices. Mesh m normals. Okay. Okay. M normals vertex ID. Yeah, I know that. I'm just like, I thought, it's like in Blender, right? You can usually do view face normals or something like that, right? And I would like to have that. Show hide. Maybe this? Nah. Oh, tab into edit mode. Mesh. Normals. Show hide? No. I think you know what I'm saying, but basically I want to be able to see the normals because right, each face has a normal, and I want to use that for each vertex to determine which one it is. You need to read it in the vertex loop. It is not in this menu. It's on the right. Okay. That's what I was thinking too. I haven't used Blender in a long time. Is it this one? Face angle, faces, centers. origins, somewhere in here. I thought it was in here. Maybe not. I don't know. Blender's changed. It's not too important though. Basically, I just want the face normals so that I can determine like that these 4 vertices are part of this specific face. You were in the wrong mode. Oh, is it only in this mode? I don't know. It doesn't matter too much though. Basically though, that's what I was wondering. Like, can we not say mesh? Or you're basically saying that I need to like calculate it. You need to save the normals in the vertex loop and then you can index it in the face loop. Yeah. For now, what we'll do, I mean, I'm just going to do this for now and then we can make this better. We'll put to do. Use calculate face normals in the vertex loop. For now, what we'll do is we'll say, which face is this a part of? Okay, so then we'll say cube face. Face equals cube face, none. I guess we'll just default to back. I mean, I don't know. We'll see if it doesn't match. Well, it should match 1. Okay, anyways. So we'll do that. We can say first normal. I think it's like AI vector 3. Yeah. First normal equals, and then we'll do is mesh normals, or I guess face indices, or faces, face index dot indices 0. And that should give us our vertex index, which we can get mesh vertices that. Okay, so that should give us the first thing. What does this give us though? That gives us unsigned int. Oh, wrong thing. Vertices. Okay, and that gives us AI vector 3D. And it should give us, we'll just take a const ref. Okay. So, yep. How's it going, Master Yoda? Good to see you. You can call source mesh m normals, source mesh m faces, m dot indices 0 to 2. Yes. Oh, I'm using the vertex. Yeah. Sorry. M normals. That's what I meant to do. Thank you. Yeah. Okay, so we get the first normal. I'm just going to use the first normal to determine what kind of normals this is. So, like, this isn't good, but we'll just do that anyways. But yeah. And so what we need to do is we need to figure out which face this is closest to. So we'll say for int I equals, yeah, we'll do I equals 0 until I is less than 6, I plus plus. I don't know if I like using I for this. Face direction, let's call it that, face direction, and then I think I can do vector 3 constant. I should have a file that I can use somewhere. Maybe it's not in here. Let's see, constants.h. I think it's in here. Okay. Yeah, okay, cool. So I do have this thing which we can do f normals 3, up, down, left, right. And I think this should match up with face direction. Cube face. Left, right, no, it does not. Okay, so we can't do that. Okay, so what we'll do is we'll just convert this to a vector3 really quickly, and then we'll fix this later on. So static glm vec3, face direction to vector, and this will take in cube face, and we're gonna say to do here. To do, replace this with a utility function. Okay, switch face case cube face front return glm vec3 1 0 0 break. Nope, don't need to do that. Case cube face back return that left return that right is that, and top is that, and bottom is that. Okay. Turn 0 by default. And we'll do that. And okay, cool. You can for loop direction and do dot product to get the mesh normal and get the one that is most similar. Yep, that's what I was doing. Just have to convert those two actual vectors though to do a dot product. So then we can say, and what we'll do here is we'll just say cube face back is 0. No, it is not. Bottom 3 4. Okay, left is 0. Cool. And we'll say cube face length. Okay, cool. We do have that. We'll say int that. Oh, and what we want to do is we want to say int that. Let's just do, because I don't like that. We'll do 0 until it's less than that. Okay, cool. And then what we'll do is we'll say glm vec3 face direction vector equals direction to vector. And we'll do the cube face that. Okay, so that should give us a vector. And now what we'll do is we're just going to do the dot product, like Sam was saying, with this normal, figure out which face it's closest to. So we'll say int min dot product. It's kind of weird because we want to find whichever one is closest to 1. So we'll initialize this to 0. And then whichever one of these dots closest to 1 is the one we want to use. So say dot product equals glm dot, and we want to do our face direction vector dotted with our normal. Okay, what's wrong with this? That's a vec3. Oh, that's an AI vec3. Let's do glm vec3. That, and what we'll do is we'll just say glm vec3 that, and let's actually move that up there. Dot x, dot y, dot z. Y, z. Okay, and that should be good. Y does not like that. Oh, it's because it's saying that's an AI real. Okay, what is an AI real? Let's see. AI real number. I just want to see if this is a type def. Yeah, that's just a type def for a float. Okay. So we can just say float, and that's fine. And Asher, good to see you. It has been a while, but that's all good. Okay, so we've got floats there. Why is it still not like this? float error type. What's error type? Is Visual Studio just being slow? Probably. Float error type. Oh, I have an extra comma. Yeah, thanks, Sam. Okay. So that's good. We now have those. Okay, we dot and we'll say if dot product. We'll just do like the distance, I guess. Yeah, so what we'll say is like closest distance equals float max. Okay, so we'll initialize it to that, or actually this should be a float. Okay, and then what we'll do is we'll say 1.0 minus dot product equals distance. Okay, and then we'll say if dp distance is less than or equal to closest, maybe we want to just do less than. I don't know, it doesn't matter too much. Then we'll say dp distance equals closest, and we'll say cube face. That's what we want. This face equals cube face direction. Okay, so we'll loop through. We'll find whichever one we're closest to. That's good. Now we have a face to add this to. So what we want to do first is we want to count everything, and then what we'll do is we'll add them all to that stuff. Yeah. It's easier to parse comma than ignore it. Yeah. Okay, so we're going through. We found out which face this is. So now we can just say, what is it? It's something down here that we were checking out. This thing. Okay. So then we can add one to this. And now we're counting, which is great. Awesome. Cool. Let's call that int. Okay, so now we can finally just say, add this to the face. Now we're counting how many indices we should have. So by the end of this, these should all have the correct number of indices. So then we're going to do this loop again. Okay. Or actually, I guess we should say that plus equals the mesh faces face index dot number indices. Okay, so we'll add the number of indices. So that way we should have the correct number so we can allocate that memory. So then what we'll do is we will allocate that memory for face index equals 0. Let's do that up here. And whoops. We will go until less than int. Like I said, this is super inefficient. I really don't care. It's an iteration of 6 times. So yeah. Okay. We're going to put to do. Optimize this if needed. And it's a loading routine, so it really doesn't matter. But anyways, what we want to do then is after this loop finishes, we should have the correct amount inside of all of these things. So we can go ahead and say face indices, face equals G memory allocate. And I think I'd do it here. Let's see what we're allocating. Size of, okay, so int star size of int times the number. Ah, yeah, we can just copy this. So we just want to do that. And do that. Or actually, we don't even need to do that. Face, actually, we'll just call this face. Okay, cool. So that should allocate the memory. Now we have that memory. We're good. Okay, so now we can start filling that memory with the actual indices. Okay, so now we're going to go ahead. We have the appropriate face here. I'm just thinking real quick. And you know what I'm going to do? I'm going to also say I'm going to zero this out afterwards. Length face equals 0. I'm zeroing this out afterwards too. So we've allocated how much memory we'll need. And I don't want to create like some other counter variable or whatever. So what we're going to do is we're just going to have this face indices. That way we can just store these things. So then what we can do here is we can say for int, we want to loop through all the vertices, face vertex, face vert index equals 0 until face vert index is less than mesh faces face index dot number indices face vert index plus plus. Okay, so now we will do this, and yes, no, we're not going to have this. We are going to count them again. We're just going to add them, but this way we know where to insert things. I just noticed I've got a bunch of errors down here. Why is this all errors? Do I have too many brackets? That's why my autocomplete and stuff has been broken. Well, that's nice. Okay. Sam, I would limit the number of indices to be only 3. You don't really want to have more or less. Oh, is it possible for it to have more than 3 indices? I thought this was like a face per like, I don't know, number, whatever. But okay, let me just put to do here. Have 3 verts max. Okay, we'll do that. I think it should, because I'm doing triangulate, which I believe right here. Yeah, so I have like the triangulate option, which I believe should do that. Mesh primitive type, check it. Okay, I will check it out afterwards. I'll look at the docs and stuff more in depth, but I just want to get this working for now. So we will eventually do that. But basically what I want to do now is block vertices. Actually, let's check it out here. Okay, so now this is what we want to do, basically. And we want to do this as well. Okay. Ooh, okay, this isn't good too. Okay, no, this is good. So we're going through each face index. Okay, cool. Wait. Yeah, each face. No, okay, this isn't good. Okay, so what we need to do is we're going to move this loop. Yeah, so this is going to be pretty bad, but I really don't care, and this is the way just to make sure this is correct. We're going to move this into this loop. No, we're not going to move that. Okay, never mind. Let's go back. Okay, so this is the face index. What we need to do now is we just need to... Wait a second. No, that was right. Okay, never mind. Okay, sorry guys. I'm thinking here for a second. Yes, we're going to move this into here. Okay. So we're going to go through each face somewhere. Where is that? Okay, yeah. We're going to go into each face. Okay. We allocate the memory. We zero it out. Then we're going to loop through all the faces in the mesh. And we're going to say if this face, which is the one that we calculate it to be the closest distance to, if that face equals, oh, and now we're going to have to, current face direction. I don't know. Wait, I got to come up with some sort of naming stuff to fix this. Okay, so if that, which we're going to fix that and that. Okay. So if, where was I? Yeah. If face equals that, then we're going to add it. Okay. So we're basically going to do this 6 times just to make sure that we are correct. And this is going to be int. Okay. And then that way we can go ahead and safely add this stuff. Okay, cool. So then what we're going to do is we're going to say face indices, face int, and this is not going to be I. This is going to be, we can calculate that int I equals this thing, right? And then what we're gonna do is we're just gonna make sure we plus this afterwards. Plus that, plus that. Okay, we're good. And then we need to assign this. So this is going to be not this, but our mesh. Okay, let's get that as a vec3. Vertex. Wait, let me think about this. No. Okay. This is just going to be this index. Okay, that's what this is. Let's remove that. That's just going to be mesh faces or face indices. Well, face, yeah. Indices. And then that. That. Okay. Which gives us an unsigned int. I think that's it. Okay. How do you know what index is for what face? That's what this is for, I think. Okay, so there's a lot of code here. I think this is right. We're going to just double check it once we actually load this. So we'll leave this for now. And that should count it back up properly. And let's make sure this loads it. Okay, let's just see what happens. Does gmemory allocate just do mallocs with some debugging info? Basically, yeah. It does some extra stuff too. If we actually go into here, it calls this thing. So it gets the file and the line number first of all. It adds some padding bytes so that I can check and see if like we have overrun or underrun the buffer. So that should basically tell us if we have a memory leak. So if I were to go into here and like say gmemory allocate, and we do like 10 ints, and then I were to like say buffer 11 equals 0, and then we do this, it'll basically yell at me and tell me that I have corrupted my memory, or at least it should. Let's see if it works, because now I'm interested to see that. It should. It like should throw an assertion error and everything, and then it should also warn me that I'm not freeing that memory, because I'm not. So, yeah. Yeah, it keeps track of the allocated memory so that it prints the program links, and then it should also tell me if I've done a bad thing. So, yeah. Sam, yeah, it was old message. You already did it. Okay, cool. Okay, guys, I have no idea if this is going to work or not, but we will see. And if it works, then it's sandwich time. And then we can call it a day. So I'm excited for that, right? Cool, but malloc returns a lot of fragmented memory. No M. No. Yeah, I will eventually like create my own memory allocator and stuff. I don't care too much right now. I'm not allocating that much memory. Like I usually allocate a few big blocks all at once. So yeah, should be good. So yeah, first of all, it tells me memory leak detected, and then it says 2078 bytes because of the buffer bytes that are used for the heap corruption detection, which it should also tell me if I do, I think if I free it, it tells me when I free it. So if I put a breakpoint here, yeah, so then it tells me heap corruption detected, buffer overrun, because I did that thing. So yeah, it's basically just a bunch of utilities to help me do that type of stuff. Yeah, cool. So that's that. We can get rid of that stuff. And then I'll eventually switch. The reason I have it wired through that too is so that when I do make my own memory manager, I can do it really easily since I'm not using malloc. So yeah, dual purpose there, right? Okay, anyways, though, I think this is basically what we need, and we should be good. And now we can just get rid of that. And let's make sure it works. Glogger info. This is just that we can put a breakpoint. And let's put a breakpoint there. So we should hit this. It should load everything. We should hopefully not get any sort of weird stuff. And it should all just work. Ah, we did not hit it. That's not good. I think we hit it. Oh, actually, I think we hit it when we start playing the game. Okay. No, we still did not hit it, but we have no blocks, which makes sense because if it didn't load them properly, then yeah, it's broken. Did it give us an error or anything? Or a warning? We've got non-standard. Okay, yeah, no vertices found for block cube, skipping loading block type. Okay. So it did tell us something was wrong. Oh, you know what it is? Is Visual Studio being stupid. Because did you see that message? Let's do this one more time. It says no vertices found for block. Oh, no. Okay, I know what it is. I'm stupid. Visual Studio is not stupid. I am. Copy that. Let's go into here. Load block map. Or load blocks. Nope. Load block vertices. This thing. We created a new function, and I'm not using the new function. I do this all the time. So we created this, but we're not actually using it, and we need to be using it. Let's delete the old one. See, this is the old one. I don't know why I didn't just modify the old one. I created a new one. And then we need to go into, I think it's scene.cpp is where I do this. No, not that one. This one. Yes. So we should get an error in here, right? We got at stuff, load block vertices. Okay, cool. Yeah. And it's doing a little tiny error that you can't even see if you were browsing this. But yeah, okay. So then models directory is assets/models /. All right, that should be good now. Sam, you should also check if the imported scene is okay. If not seen or scene M flags incomplete. Thank you. That is a good point. I think I do check to see if it's null pointer. Did I or did I not even check that? Yeah, I don't even check that. That's a good idea. If not seen or seen M flags. Thank you. This was a good point. And AI scene flags incomplete or not seen root node. Thank you, Sam. Yeah, I was harping about error catching and all that stuff, and I didn't even check for the most basic thing, which is it didn't load. Okay. Scene failed to load for mesh, or I guess for file, for block type. And we'll print out the file, model file .c string. We don't need to print the full path. And then block type string .c string. And then we'll say skipping loading for block type %s, and we'll do this thing again, and we should be good, and we'll say continue. But if you notice, the whole world loaded. It just didn't have any cubes, which is great because that tells me that this will work. We might like throw some sort of default model that's like a broken model so that if it ever fails to load a model, then when we load up the game, we're like, oh, look at that thing. That's a broken model. But yeah, I was pretty proud that the game actually loaded. It didn't like completely die. Yeah. There's also mimporter.get error string. Thank you. I was wondering about that. Glogger. We'll do it down here. Or just /n error %s. That was m importer. I think I just called it importer.get error. Sweet. And is that a const char star? That is. Okay, cool. Sweet. So let's run this again. You can add the error method with the pre-message. Yeah, that's what I did. Cool. Vox riffs, that can be a sandwich. Yes. We'll have the default model for broken models be a sandwich. And then if you see sandwiches in your world, you got a broken game. If this works though, guys, this is like a pretty good step forward for this game, because now I won't have to handwrite vertices and I can have my brother's design stuff in Blender. Okay, so we've hit the breakpoint. Did we get everything correct? Let's take a look. Let's delete this stuff. We should have like block vertices. Yes, and I think this is the current one. Yes, okay. So we got block vertices. Let's see, we've got number verts 24, so that's a good sign. Number of indices, how many do we have? This is not a good sign. So we have 0, 0, 0, 0, 0, and then it says that they're all part of 5, 36. So something's going wrong there, where it thinks that they're all pointing whatever 5 is. What is 5? Cube face. Let's go and find. That is back. Okay, so they're all defaulting to back, which I think I know why they're defaulting to back, because that's the default here. Yes, that's not good. Let's default to length here, since I don't have a none. And then we'll say if face equals cube face length, we've got a problem. glogger error invalid face. And what do we want to do? We want to do for the normal, which is a percent 2.3f. Invalid face normal, so we'll do that. That and that. Okay, and then we'll do first normal dot x. Okay, I think this is what's happening, and then what we'll do is we'll just do a continue, which really isn't good, because then that means we're this should be an assertion. Okay, if we fail here, that's an assertion failure. So let's do that. glogger assert face does not equal cube face length. Okay, copy that. I think there's one other place we have this. There is. It's right here. Let's do that. We will initialize this to length. Okay, let's run this again, and I think we're going to hit an assertion failure, and I am interested to see what it is. No, we did not hit an assertion failure. That is interesting. All my assumptions are wrong today. That's usually true, though. Block vertices. Let's see. Yeah, they're all just going to 0, 0, 0. They're all going there. That's weird. Is it because of the way I did this? Oh, I think it is. Wait a second. Yeah, we need to make sure that's also greater than 0. Yeah. Just realized that. Okay, so let's do that here as well. Okay, let's try this again. This should fix it. I guess it... Ooh. I might have to check that again one more time, because that still isn't quite correct. I think that'll work for now, but it's not quite correct. Block vertices. We've got... still wrong. This is weird. Let's put a breakpoint in here. Okay, we'll put a breakpoint in here. I think this should actually be a GLM absolute because we actually want to do the absolute value of that, and then we'll say GLM absolute. Okay, I think that's actually what we want as well. So let's just fix that here too, because this could be like slightly negative, but it's still close. So I still want to account for that as well. Let's see what we're getting in here. Okay, so we hit this. What is our face direction vector? This is 0, 0. No, that's not what it is. It's 0, 0, -1. And what is this? This is 0, 0, 1. So what this should be is z positive, which is the right axis, is what we should get. We get dot product is -1. So that should hit this because we're at float max right now. So then that gives us DP distance is 3.4. Oh, wait, no. Yeah, that's not good either. We don't want to do absolute value here. That's not good because then it's going to think that -1 is correct when -1 is the furthest from the what it should be. Let's check this again. Didn't I set it to 0? Don't think I did. It's set to float max right here. Yeah. Okay, so let's see. Dot product is -1. DP distance is 2. Okay, so that's far away, which is what it should be. So then we get DP distance should equal closest. Oh, I'm an idiot. Closest distance should equal DP distance. That's backwards. And then I don't think that, so I think we had it correct. I just had that wrong. Yeah. Is that right? Wait, let's see. Closest distance equals DP distance. Yeah, I think that's what, I think that was wrong. Yeah. Okay, so this was actually correct the whole time. Let's change that and change that. Change that. Okay, let's try this again. We'll just walk through it real quick, make sure it's correct, and then we can let it run and see what happens. Okay, so we get DP distance. This is dot product -1, 2. Then this should be 2. Okay, that's correct. So if we go ahead and we continue to here, and I get rid of that, we should get closest distance is 0, and we get face direction vector right. Okay, so it's the right face, which is correct. Cool. So that looks like it's working. Now we'll continue to that breakpoint. Let's go to our block vertices, make sure these are correct. There we go. Okay, so now we're getting 6 for each bucket, which is correct because each face of a cube has 2 triangles, which should give us 6 indices per cube face. Let's see if this works. Okay, so we got this, load, and let's see what happens. Okay, well, that's not right. They're cubes though, so that's good, right? It's just messed up texture chords. It should be, the absolute should be here 1 minus absolute dot product. Well, no, we don't want to do the absolute value of the dot product because if it's 1 and -1, like -1 is the furthest away, which would give us 2, and that's actually the appropriate behavior. Yeah. I know it's cubes, the texture chords are all just messed up. And some of the faces are messed up too. You know, this is pretty cool. We got animations now, guys. I just did that really quickly. Animated blocks, what do you think? Let's get a cube up somewhere so we can actually see what's happening here. Wow, that's giving me 4 cubes. That's why. Oh, you know what it is? That's what it is. Okay. Look at that. Okay, so 1 cube is actually the size of 4 cubes in my game because of scaling. Well, this is good. So this is actually working properly. And what we need to do is we just need to go into our Blender file. And if we scale 0.5, save, export. I'm really hoping this works. If this works, we're on to sandwich time, okay? Export. Run this. Okay. Play game. So that was just like a bunch of... Oh, I should have screenshotted that. Yeah, too late now. Okay, no, that did not work. What's wrong? We still have this wrong? This is still a big cube. Why is this still a big cube? You need to apply the transform to the mesh in Blender. Oh, did I? Oh, thank you. Yeah. Let's check the dimensions on this too real quickly because I just want to make sure. Okay, so this is 0.5, 0.5. So 1 meter by 1 meter by 1 meter. Yeah, before what it was 2 meters by 2 meters. Yeah, cool. So this should give us the proper scale. And then I just need to, when I export, like Sam said, FBX, we need to apply that transform, which we can do right here. Scale, apply transform. Why does it say experimental? I don't know. Okay, let's see if that fixes it. Because like this, you would need the matrix and async and then async and then transform it inside the game. Yes, that is true. Which I might do too. I don't know, because... Whoa, whoa, what's happening? Whoa, this is not right. Okay, guys. We're in a column of cubes. I don't know what's happening. I'll screenshot it this time. It did say it was experimental. I guess this is the experimental part of experimental. Let's re-export it, and then I'll just apply it in the game. Strange stuff, man. When they say experimental, they really mean experimental. Cube.fbx. Did I hit the right button? I think I hit the wrong button. Export FBX. Let's not do that. Okay, so Sam, like you were saying, I just need to... Oh, it's not... Okay, it's not part of the exporting. It's just Control A to actually apply it to the model. And experimental because FBX is Autodesk closed source format. Gotcha. Thank you. Heavy rain. Good to know. So if I hit Control A, that's what you were saying. Let's try this. Okay. Export. Let's rerun this. I see what you're saying now, though. Thank you, Sam. Okay. Does it work this time? And Essie was just revealing all of your secret cube textures in one go. Exactly. Okay, so that worked. But now the texture coordinates are still off because the cube is too small. Oh, it's because it's offset weird. Yeah, you can see this is where it should be, but it's offset down to here, and it's getting like a quarter of each texture. And you know why that is? It's because it's not... I want the bottom left corner of it to be at 0, 0 is what should be. But actually, we can fix this. No, actually, screw that. Let's not do that. Let's do this. Play game. Put it in here. So what's happening is in the shader, I was compensating for this stuff. Inside of opaque shader, if we go... You can see that I shift everything by minus 0.5, which is not good because this is kind of doing more stuff than we need to do. So instead of shifting, if we make sure everything is centered around the origin, we should be able to just do that. Oh, wait, we don't even need to, well, yeah, we do need to transform it still. That's for rotations and stuff. But yeah, we just need to do that. Save. And then if we go into here, reload shaders. No, that did not fix it. So before what I had was this, which was subtracting 0.5 plus, Where is it located in Blender? Location 000. So that's all right. Let's see. I think I had, let's see what I'm doing in the other places. Because I had, we don't need this anymore. This is good though. We're making progress. Almost there. Cool. Let's go up here to where we parse it. Okay, yeah, so I check and see if it's between 0 and 1. So let's do the same thing here when we're loading these in. And we'll do whatever we were doing here too. We'll leave it as 0 if it breaks. So copy that. So when we import it, going through the vertices. Okay, here we go. So what we'll do is we'll say this. If is less than minus 0.5f or x offset is greater than 0.5f, we will say error, and then we'll say x offset equals 0 if we get this. X offset is %2.3f, which is invalid. All offsets must be between negative 0.5 and 0.5. And we can change this too in the future. I should probably remove that f. Okay. And block type %s, skipping vertex. Okay, so then what we'll do is we will change that to be x offset and block type string.cstring. Okay, and then we'll just do this for each of our vertices. This way we can see what data is wrong, and it should be a little bit more apparent for us. Okay, let's do that. Okay, let's see if we get some errors, which I'm assuming we will. If you don't want to do that apply scale every time, you can call AI process pre-transform vertices, and we'll transform meshes by the parent transform set in Blender. Thank you. I will do that. I want to see if this does, because it looks like it did scale the cube down. Did we get errors up here? I saw 2 errors. Yeah, so see, like we're not getting any errors. So I think they are between minus 0.5 and 0.5. I feel like I'm just missing something else. Was I affecting the transform in other places too? Let's just check this real quick, because I might have been actually like transforming it weird to compensate, which wouldn't be good. And then if we look in the shader too, actually, where I get the texture coordinates. Yeah, okay, so we do text coords. Oh, and we're gonna have to shift the texture coordinates. So this is what's wrong with the texture coordinates now. They're gonna have to be shifted, because if we're between minus 0.5 and positive 0.5, we actually want it to be between 0 and 1 for texture coordinates. So what we have to do is modify our vertex offset. Yes, okay. So we get this, and then what we need to do is, so we're flipping the y coordinates there. We just need to add 0.5. So that should fix the texture coordinates. Let's check and see if that works. And then I think I'm actually modifying the cubes in the vertex generation for our chunks, which is what we'll have to fix afterwards. Okay, so that's not quite, I think, let's see, what's wrong here? Oh, because we can't do plus 0.5. Whoops. That makes sense. We need to do half of, yes, yeah, you're right, before this scale right here. So let's do this. So it should be like that. Yeah. And then we'll do this, same thing here. Plus 0.5, which I guess would just be, that's equivalent, should be. Okay, so I think that should be all we need to do, right? Math shouldn't fail me. Okay, there we go, cool. So it's still offset wrong, so we need to fix that. We also need to do this inside of our transparent shader because I have this stuff duplicated, which I really don't like, and I will fix eventually. So let's go and fix that here as well. So this should be plus 0.5, and this should be 0.5. And then we also need to fix this. We no longer need to do this stuff, which is good. Okay, and then if we go that, there we go. Everything is as it should be, except for those. We'll fix those. Yeah, I kind of like it though. We should keep it. Okay, Vox riffs. Shouldn't the 0.5 be before? Okay, no, it'll be 1.5. Okay, never mind. Yeah, I know. Math is weird, but I think this is correct. Because I mean, if you're doing addition is commutative, so it shouldn't matter if you flip it or if you just do it. Yeah. Okay. Because I was thinking the same thing, voxel refs, and I was like, wait a second, but it should work. So, yeah. If we go into chunk though, okay, so we do this. We go into here. I have a feeling we'll find like a minus 0.5 or something somewhere in here, which is why everything is off. Or maybe not in here. Actually, no, you know what? It's not in here. It's in player controller.cpp. And if we look for raycast, where we're doing our raycasts, this is where it is. I'm guessing, I'm thinking it is. Do we draw it in the wrong position? Render or draw box? Block center, block size. Yes, wait, where's block center? Block center, where's that? Res.block center. Is it in the raycast itself? Is it? It is. It is. This is really not good because, yeah. Wait, is it? No, I don't think it is. Wait a second. Sam, since now your vertices are signed, just to check if you don't have anywhere set that vertices can only be unsigned. Maybe the texture format? You might have to repeat that again. I'm looking for where I think... Is it in the player controller? Now I'm confused. Where is this happening? Because clearly it's... Oh, or maybe it's happening in the line shader? This is what happens when you do these weird transforms. I did it as an ugly hack, and I should have never left it in there, but I did. Let's see. Where is it? In Debug Shader 3D. This is where we draw lines. I don't think it's in here either. Is it in here? And draw a line. 3D. Or I guess that's just draw a line. Let's see. No, doesn't look like it. About draw box. So that's the center minus the size times 0.5. Yeah, that. Oh, actually, I think it is in the player controller. Wait a second, because we have to shift it. Because this is going to give me the block position. Wait a second, is it? Okay, I'm getting all sorts of confused now. Let's remove this again. Go into here. Where do we set block center in here? I'm really confused because I'm not sure if these actually are at the correct coordinates and stuff, and I'm just drawing the box at the wrong place. Okay. So no matter where I place my mouse on this box, it is here. So I think the raycast is definitely raycasting against that space. Sam, so try to break something if the edges are current. Well, yeah, I mean, I think it is affecting the correct block and stuff. So if we go back into here, I think it is. Yeah, because that's definitely the correct block. It's just offset. These are all offset correctly. I mean, correctly according to where they should be, because I'm doing it differently there. Wait, did I do the shader right? Maybe I did just do the shader wrong. So before, what did I have? Before I had inside of here. That's fine. Before, what I had was this was shifting down. Oh, and then it was adding it back. Ooh. So we are going to have to add an ugly kind of thing. I think we have to do this. Plus that. I think, yeah. Yeah, it looked like I moved, but the whole world moved. Yeah, that's correct. Okay. And now these are all off because they're just at the incorrect locations. Okay. This is correct. I don't like that I have to do this to get it to work that way. So maybe I'll put a to do and like figure something else out. But this is correct. Like these lines are in the correct space in 3D. And so this block actually is right here. Let's just put to do in here and say like, to do, I don't like that I add a magic 0.5 here to offset block to the correct world position. And let's also say that's a note, just so I don't forget. Tenkunk 555, best followers, primes, and viewers. Ah, spam. Nice. Voxers, cold lines because of water. Yeah, I gotta fix that eventually. I started looking into the cold lines and stuff because of water, but I never did fix it completely, so I'll eventually get back to that. Let's fix the transparent shader real quickly too. And thank you, Langors. Let's just do this. Fix that as well. We'll add the same note. And we'll do that. Okay, and then if we go back in, this should fix the water. Okay, now the water's correct. Everything should be correct. That is all good. Cool. Okay. So now we just gotta fix this stuff, which we can do by modeling it in Blender and then doing that. But first, since this is working, let's do a sandwich because that's what everyone wanted. So we now need a sandwich. So to add a new block, what we should have to do is only go into blockmap.h. We have block type somewhere in here. Yes. Okay. So we will add sandwich. Okay. And now we should be good. Let's see how good my Blender skills are. I'm guessing they aren't going to be very good. So let's go ahead. We'll hide this. I'll say Shift A, cube, scale 0.5. Okay. So this is, let's rename this sandwich. Okay, and this is indeed 1 meter by 1 meter by 1 meter. Let's go into tab. We'll say I. Nope, that's not what I wanted. I want Control R. Loop cut. Yeah, there we go. We'll do 2 loop cuts. Okay, we'll put one of them right there. Put this guy down here. Okay, and then we'll go ahead and we want to extrude this, I think. How do we extrude along normals? Extrude along normals. How do we do that? I know there's a way. Extrude. Or maybe I'm thinking about this wrong. Wait a second. Mesh. Let's just Google this. This is the easiest way. Blender. Extrude along normal. Alt-E. Okay, so we do Alt-E. Extrude along faces and normals. I think that's what I want. Yeah, there we go. Okay. So that is our sandwich. I will fix the top, hopefully, because this is not a very good sandwich. Is modeling in Blender similar to Fusion 360? I'm not sure. I haven't used that software, but I do like the way Blender works. It's got a lot of awesome key combos and stuff, which makes it pretty easy to work with. Okay, guys, what do you think of that? Is that a good sandwich? Let's also move it up so that it's about centered. I probably should have done this mathematically or something, but it's done. What is done is done. That's good. Yeah. Pretty good sandwich, I think. We need to get texture for it too, and this is going to be the next hard part. You got to have the iconic bread shape. What's the iconic bread shape? Like having corners here or something? Or a lot of work. Hello. I was thinking about a sandwich with multiple layers. Your bottom of the bottom needs to be on -1 on the Y. Well, no, I want it to be centered on the origin. Oh, wait. Yeah, you're right, Sam. Yeah, you're right. Because this will be a floating sandwich. Maybe we can work with floating sandwiches first, though, and then we'll do that. You're a sandwich genius. Thinking multiple sandwich with multiple layers. Let's add one more layer. We'll see how that looks. Oh, whoops. I did not select all those vertices. This is my Blender skills, too. So now you guys know I am not very good at Blender. G, Z. So we'll make it a little bigger. And then we'll do another loop cut here. Right? And then we'll do, let's do 2 loop cuts. Control R. There we go. So that'll be our second layer. And then we can say Alt-E. Extrude along normals. Kind of do that for our bigger one. And then these guys, yeah, we'll make this one a little bit bigger as well. So we'll do like that. Nope, I selected too much. That. And then we want to deselect this. and that one. Okay. And then we'll do like scale along the X and Y. There we go. Kind of like that. Let's see. Okay, and then I think I just need to make them thinner. So then we will go say like G, Z, squash that down a little bit. Squash that down a little bit. And sandwich. Yeah. It looks more like a weird column. We'll call it a sandwich for now, though. Now it looks delicious. I hope so. Let's go possess floating sandwich for now. Sounds good. So if we go ahead and we say export the model as an FBX, we should just be able to say sandwich. Okay. Export. Oh, and I actually have to do apply that. Let's export that one more time. Export. Cool. So now if we go into here, we can just go and add sandwich. And we should be able to just say model file. That. And let's also remove this stuff because we don't need it anymore. Cool. So that should be it. And then what we can do is we also need to add like a block that is a sandwich block. So we just go into here and we'll say sandwich is ID 64,000. And this is going to be, we'll add what? I don't know. Does Minecraft, we'll add like steak for the image picture? I gotta see if I have that. Let's see. If we go assets, images, item, steak. No, we got stick. Beef, is it called? Okay, so we got beef. I thought it was steak when it was cooked. Cooked steak? Yeah, cooked beef. Okay, and then we'll have the, I don't know, maybe that. We'll change that later. For now, this will just be that. Let's see, what else? Block type is sandwich. Side is going to be, we'll just do stone for now, and then I can like make better pictures eventually. Top is going to be, I guess, sandstone, maybe. Who the hell eats sandwiches layer by layer? I don't know. Who does that? Okay, and then bottom is also be sandstone. I think that's right. Is it? Let me just make sure. Images, block, sandstone. Or we'll just do sand. A sandy sandwich, okay? I think that sounds good. Not really. It sounds disgusting. But okay, so we've got a sandwich block. Now if we go, fingers crossed, nothing breaks, and we should be able to just put it in there, and it should have those textures, and it should just kind of all work, maybe. We'll see. The ultimate test to see if my code is not as brittle as I think it is. Also, sorry about the latest video taking a while. I have not worked on it nearly as much as I should have been, but I have finally started to gain some momentum and it's making some good progress. So hopefully that'll be out with like a week or something for the next episode in the OpenGL series. Okay, let's see. We broke. Let's see. This was in. Can we just hit continue and does it give me an actual error? No, it does not give me an actual error. That's not good. Let's try that again because it was broken. I think it's just because I broke something else. Let's see. Load blocks. I need to add that thing. That's not defaulted. Let's actually default that. So let's say is defined. And then we'll do that stuff. Otherwise, we'll default it to true. Okay. Cool. So I was just missing a property there, and it was like, you don't have that property. I should have error handling in here, which I don't. If we had error handling, I wouldn't have had to do that debugging. Okay, so if we load it, we can give ourselves a sandwich now. Don't forget to add to do for AI process pre-transform vertices if you don't want to care about apply transform. Thank you. I will do that. Yes. All these lights are messed up too. That's not good because I think they're messed up because of that offset thing. We'll fix that stuff later. Oh no, I need to add room. Okay, there we go. We've got the steak, which is actually a sandwich. And if I place it, that's not a sandwich. Oh, that's disappointing. It does have a sandstone top, though. And it does have a sandstone bottom. Why are you not a sandwich? Did I do the block type right? Okay, block type is sandwich. We do have that here. We do have that here. Did I export the wrong model? I might have just exported the wrong model. Okay, let's exit there. Export FBX. Selected objects. Okay, yeah, so it should just be doing that. Which is that. Did we have any errors here? No. Let's load this one more time. Let's see if it fixes itself automatically, because I'm not sure what's going on now. Still that. Let's go into chunk and see what's going on. Let's add an if statement here so we can break on it. Let's see. We are looking for block format, subchunk, block vertices. Okay, block type. Here we go. So let's say if block format dot block type equals block type sandwich. Okay. Put a breakpoint there, and let's see what happens when we load that. Maybe that default cube was hidden. That's what I was wondering, like if it's picking up the wrong stuff. We'll check the vertices and make sure it's correct though real quick. Let's see. So we do hit it. So we are getting the correct block type and everything. That's good. Block vertices. Let's go ahead and see what those are. So, yeah, it looks like we got 24 vertices. So that's definitely wrong. It's definitely got a cube in there for some reason. Why are you loading a cube? So let's go then into blockmap.cpp. What is it called? Load that. Let's see. We'll say if block type equals block type sandwich. Okay, breakpoint. So forgot to set the path for the file at import. Oh, did I hard code? No, I don't think I hard coded the path. Maybe I did. We'll check that in a minute. Okay, so it's loading it from the file. That's good. The model file is sandwich.fbx, so that's correct. Asset/model/sandwich. Okay. One mesh. We get 24 vertices, 12 faces. Okay, so the FBX is definitely wrong then. Why are you exporting the wrong thing, Blender? Okay, so I'm selecting this object. Can I just like right click and set export? No. File, export. FBX. Selected objects. Oh, it's hard coded in there? Oh. Did I really hard code it? Wait a second. You are right. It is hard coded. Thank you. Okay, that's why we're not getting a sandwich. Model file .cstring. I don't know why I did that. Thank you. Okay, so now if we remove this, we should be good. Let's see if it works now. Okay. I'm expecting it to break, but we'll see. I'm really hoping it'll work, but usually it doesn't. I mean, the cube worked. That's easy, but a sandwich is pretty complicated. Would you look at that? We got a sandwich. It's rotated the wrong way, but that is definitely the model I had there. Success. Yeah, we did it. Okay, let's see why it's rotated wrong. Blender axes are flipped. Oh yeah, because the X and Z are different. True. Can I change that when exporting? Do I have options here? Let's see. Forward is -Z forward. Okay, so X is forward. Positive X forward. Export. And now we should have it correct. And if that's correct, we're in business. We got it working. That's awesome. And I am amazed that it worked. Okay, no, that's still not correct. Why is that not correct? Can I define the up vector too? File, export. FBX. Oh yeah, I can define the, okay, yeah, so X is forward, Y is up, all scalings, local. Oh, I think I need to do what you were saying, Sam, and I need to now apply. Okay, let's just do that. So if we go into our loader, let's say, or AI process, apply transform. Apply transform. No. Transform, pre-transform vertices. There we go. Okay, let's try that and see if that fixes it. And then if it does, I think we're good. Uh-oh. That's not good. Whoa, why are we getting like 43, -5, 12? That's weird. Why are they so big if it is smaller? Scale of the scene. Why does Blender scale the scene too? That's not cool. So if I go to, how do I do scale scene? Let's see. Scene, gravity, units. Unit scale, 1. Separate units. What's that do? Is it because of this? Oh, is it converting it? I think I see what you're saying. So if we do none, is that going to convert it? Maybe I have some node in Blender scaled? Collection. Collection, scale 111. I think this is just like the scale of the actual object itself. Here, let's Google this. Assemp pre-transform vertices not matching Blender units. Okay, let's see what this guy says. Using latest version of ASIMP, have you used the transformation matrix of the root node? FBX model, okay. Up axis is usually taken from the file format specification or from description of camera. Well, that's not that much help. Scene collection. Does this have anything? Okay, unit scale is 1. Looks like the root node has big scale. Wait, did I miss something? Scale is 1. Scale is 1. Sandwich is 1. Is there some other thing that I'm missing here? Can I pull this out of the collection? Okay, here. We've pulled that out of the collection. Let's do the same thing for cube. Okay, and then let's just delete the collection. Delete that. Okay, we'll leave the camera. We don't need the light though. Delete. I don't think we actually need the camera either. We'll delete that. Okay. So cube is scale 111. Sandwich is scale 111. Okay, let's do that. Let's do export FBX. Apply scalings. Scale is 1. Apply unit. Oh, maybe, okay, it's probably that apply unit. Okay, let's turn that off, see if this works. Nope, still broken. It looks like what's happening here is it's converting it from like meters to centimeters or something. Or centimeters to meters or something, is what I'm thinking. Oh, you mean root node in ASIMP in the, okay. Let's see what we get here. If we hit a breakpoint here, scene, root node, transformation, 111. Doesn't look like it's doing anything there. Let's get rid of transform vertices and then try this again. I might just multiply it myself and we'll see what happens. Okay, we get that and we get scene, root node, transformation. Yeah, looks like they've got, I mean, that all looks correct because it looks like it's just flipping the vertices. Or no, that even just looks like the identity. Yeah, that's weird. Why is it just the identity matrix if we have it said to be flipped? Let's see what happens if we load it again, because now I'm interested. Yeah, still flipped wrong. Weird. Let's, oh no, I forgot to put the breakpoint. Wait. Okay, let's go back into here. Not sure if this is your issue, but I have set -z forward up and y up. Yeah, I have. So in my actual game world, it's like X is my positive axis, which is why I want it to like transform to that. But, and that's what I expect it would do, but it doesn't look like it's doing that. Let's see if the mesh has a transform. Texture chords, methods, number meshes, bones, primitive types, vertices. don't see anything there for like transforms. Private name, textures, root node. What do we get in the transformation here now? Yeah, this is just the identity matrix. Root node, transformation, children, number meshes, metadata. Weird. Transforms are in the nodes in root node. In the nodes. Well, that's why I'm checking is root node here, and then it says M transformation. Oh, you're saying in like the children. Oh, okay. So if I go into here. Okay, here we go. So transformation is 100. Yeah, so this is definitely wrong. So it's multiplying by 100, which sounds like it's going from... What is it doing? Like meters is 100 centimeters, right? Yeah. So it's transforming it to centimeters for some reason? Okay, thank you, Sam. Yeah, that should tell us what's happening, though. I think we just need to... Yeah, meters to centimeters. Yeah, that's what I thought. So is it... So if we change this to... Or can we go export and like do something about that? Export FBX. Geometry. Okay, that's that. That's that. We don't care about that stuff. Unit scale, maybe? Let's try that. Let's see what happens. Export. Maybe it's not applying it or something. I don't know. Or like Blender defaults to centimeters, and so it's doing it in centimeters or something. I'm guessing, because that's what it looks like. Okay, if we go to children. Come on, children. Oh, I didn't load it yet, did I? No, I should have loaded it by now. Yeah. Children, let's see, root children is that 0 meshes, but it says 1 mesh. What's this say? This is just the identity matrix again. What the heck? Am I missing something here? And meshes. There was default unit for meters and centimeters in the scene settings. That's what I saw too, and I didn't think that's should affect it on export, maybe. But what's weird now is that this is just like it says there's 0 children. Okay, what if we do that? Yeah, so it's definitely still applying it weird. So yeah, we got this unit system. Let's see. If we export BX. See what I think is like, okay, this apply unit. FBX unit scale. Let's use all local. Take into account current Blender unit settings. If unset, raw Blender unit values are used as is. So yeah, that's what I assumed that would do. Like, I know, yeah, the transform was, it did change to 100 when I changed it to centimeters. But if I'm applying the unit, I would assume that it would like not be using this. If that makes sense. Because like if I hit export FBX, take into account current Blender unit settings. Current Blender units settings. Unit scale is 1. Wait, what does this say? Scale to use when converting between Blender units and dimensions. When working at microscopic or blah, blah. Yeah, and I'm assuming if we're doing meters, it's going to keep it in meters. What happens if I do 100? What happens if I switch this to centimeters? Yeah, it just changes that, but it doesn't change this. I mean, I could just do this easily and just divide by 100, which I might do. The transform was 100 when you switched to centimeters in Blender. Set the unit scale to 0.01. Okay, here, let's change this back to that. Let's go, where is this? Centimeters? I don't know, or just do this one. Okay, let's just do this, and then what we'll do is we'll say 0.01. I don't like that, though. What the heck? Yeah. What's going on? I think what I'm going to do is I'm just going to divide by 100 in the mesh. I mean, in the code. So we're just going to assume it's coming in as meters or centimeters, and then we're going to... Yeah, we're going to assume it's coming in as centimeters and transform it to meters. Langors, make it in meters and make the unit scale 0.01 like Sam said. I know, but I don't like how that, like, now I can't see the grid squares and stuff. I don't like that. I like being able to visualize like how big 1 meter is and stuff. And so, I don't know. I think it's just easier to do this in the code at this point. No, in export. Oh, in export. Oh, okay. Was I missing something in export there? Oh, do it here. Okay. Export that. Let's see if that works. Okay, yeah, and then it's just broken for cube now. Okay, so now if we just re-export the cube. Thank you. Okay, that's what we needed to do. Okay, so then if we do this, we re-export this guy. 0.01 by default. Cool, that's what we want. Cube, export. Okay, there we go. Thank you, guys. Okay. That was way harder than it should have been. And now we're good. And now it should be rotated correctly, hopefully. And now it's... Okay, okay, there we go. Finally. That took way longer than it should have. Sweet. It's good. All of these ambient occlusion values are messed up now, though. I don't know why that's all messed up. I will have to check that. That's not fun. Man. Whatever. At least we got sandwiches now. Very gross sandwiches, but sandwiches nonetheless. It's still weird that it's converting to centimeters on export, but it's fixed, so that's what matters. Yeah, I know. That is very strange. But like you said, yeah, that is what matters. Cool. Okay, so now we can add new models very easily through Blender. So if we were to add a fence post, create it in Blender, we can export it now, and then we can just do all that stuff. That's good. That's what I like to see. I will have to fix this in my off time. I think I'm probably going to end the stream right around here because we did do what I set out to do, which is exporting models through ASMP. Awesome. Well, thank you guys for watching. I hope you enjoyed it. If you rotate the model in Blender, the UV will be different. Yes. And that is by design, I think. Yeah, it's... Whoops, I fell down into a hole. I think that's by design. And I can't fly. There we go. Okay. Because of the way I want it to work. I'll have to figure out something for like texturing. I may come up with a different system entirely to do texturing to fix it, but that's down the road. This is it though. I hope you guys enjoyed it. AO will not match. Yeah, gonna have to fix that. I was going to say, if you guys enjoyed this, please hit like and subscribe, but I'm assuming you're already liked and subscribed to the YouTube channel. So anyways, I'll see you guys next week. If anything comes up, I'll let you guys know and go with that. Yeah. Good stream. See you guys next time.